Okay, we're live again. Sorry, guys. Welcome to the Azure and AI Show. A few minutes late starting this week, but we have some new speakers. We have Reddy. She's going to do something uh, using Azure Vision and analyze diagrams and flowcharts with C Sharp. And then we're going to have Precious. She's going to do some stuff there on Azure load balancers. And Venkata is with us here, and he's going to do some cloud innovation in health insurance, driving efficiency with Azure and AI. And we have Dan Ray with us this week, and myself, Frank Falvey, as well. So, Dan, you were just going to show us something there. I'll just
Yeah.
put it up on the screen there. 1 second now. I'll just take this one down. Put you up on the stage, Dan. There you go.
Okay. So you should be able to see my LinkedIn, and I'm over on Frank's profile. So I could do this from my phone, or I could do this from a browser. And if I click into the post where Frank has gone live, and I right click on the post tab and mute, I'll be able to see from a phone or another device what I am sharing through the session. And then if I come to the StreamYard tab, because I'm sharing the StreamYard tab, you can actually see the StreamYard interface. And because the little, I guess it's a computer monitor icon shows up, that's how you're seeing whatever I bring up in my browser. So if I brought up like a PowerPoint, or if I brought up a Excel document, or if I brought up a website and I have that website in focus in a new tab or an existing tab, that's how you can see what you're sharing. And if I share StreamYard within StreamYard, you get like this kind of ghost effect. But one thing that I can do with StreamYard is take a look at both the thing that I'm sharing, and then from either another device or another window potentially, I can take a look at what other people are seeing from StreamYard. The trick is you don't want that other window to be playing audio, or you get the chance of feedback where what you're saying is echoing either to yourself or to the entire audience. So if it's on your phone, it's an easy option to just mute, and then you're not causing yourself that that background noise or that echo. And then if I had a PowerPoint that I need to present, I can type in PowerPoint.new, or I can bring it up in a browser, Google Slides, whatever the share might be. And then if that is the focus, and I'm sharing, in this case, my browser window, you should be able to see presentation 46, because I do this demo a lot. And that's what's being shared by Frank in StreamYard to all of you, our audience. So hopefully that quick demo, Frank, of StreamYard and how to present in StreamYard is helpful for those that might want to join us in the future and either haven't used StreamYard or are still getting used to StreamYard. You can upload your slides and share slides, and I believe they become PDFs, so you might lose things like animations or builds. But if they're just standard slides, 1 through 10, for instance, you can upload those to StreamYard, and then Frank, as the producer, can decide if those are on the stage or if it's only us. And you as an individual decide if you are sharing your video or your audio, muting your audio or turning off your video. So Frank, that's what I had for today.
Okay, thanks, Dan. I just move that one, and there we go.
So, hi everyone. Glad to be here and thank you for the opportunity. My talk today is about beyond text using Azure Vision to analyze diagrams and flowchart with C Sharp. In manufacturing, so much of our knowledge is locked inside visuals, like maybe SOP diagrams, inspection workflows, decision trees, and they are usually stored as some images or PDF that you can't really search or reuse. Um, I think about this like a dark room full of photos. You know there is something, but you can see them. Um, in manufacturing, data isn't the new or data as a oil. It's more like sunlight. It's everywhere. Um, Cameras, maybe sensors, um, operator photos, and sometimes it's in the mind who is working. But without a right system, it just disappears. Little bit about myself. I'm Ritisha, working as a software engineer in manufacturing and test automation for the last 8+ years. And a big day in my day-to-day activity, I collaborate with engineers and test teams who rely on visual artifacts, flowchart, process diagrams, inspection document, uh, to see how the processes communicate across the pipeline. So tonight I am kind of showing a practical approach using Azure Vision with C Sharp to analyze the diagrams and flowchart and turn them into something more usable in modern engineering workflows.
And your second slide never came up. Yeah,
There it is.
yeah, that's it there now. Yeah,
The
computer.
this is
flowchart,
Yeah.
Yeah, thank you for letting me know. So computer really treat a flowchart like a photo of a cat when we consider from the manufacturing standpoint. Usually BPMN, which is the business process model diagram, has a lot of SOP, the logic where we can take the decision. But in the current scenario, it's just like a image. There is no metadata, no searchable steps, no decision, no logic. It's just like a bytes. Um, but what I'm trying to propose in my practical approach here, instead of that image, the better way is to show it as a structured JSON with captions, tags, ordered steps, flag decision, which can then connect to a knowledge graph, and we can get the real insight out of it. So as I have iterated previously, the problem statement is really clear. We have the files, which in our terms, we call them as a dump files when the image is just flat, and that costs manufacturing teams. Um, so the practical approach is to use the vision and the OpenAI search from Microsoft as one single pipeline, which can extract which from where vision we can extract the insights, and the OpenAI search classifies and turns into structured JSON output. For the live demo, I'm taking MVTech industrial data, which is kind of freely available as an open source. We cannot use the real data, but that stand in a par with what the real scenario is, and then a synthetic flowchart as a data, and then live out with the future prediction for visual intelligence in production. So let me start with what is digital asset management in manufacturing. A DAM, which is a term that is used left and right in manufacturing, which is basically organizing, storing, retrieving rich media assets, managing permissions, metadata, and rights at scale. which is
Are
very
you
different
are
in.
you on a different slide? Just so you know, we're still seeing the computers treat a flowchart like a photo of a cat in the share.
Oh.
So it might be on your other monitor. There you go.
No,
Now we see digital asset management.
my both of the screen has the same visual, meaning that digital asset management in manufacturing is what
Okay.
I see from my side.
We just saw that now. That just came up. So whatever you advanced changed it for us. But we were seeing the cat one before.
Okay. I think there is one issue. So when I hit the play button, both of my screen is captured with one slide, and that's what I see.
Okay.
And
Maybe
then,
don't use the play button. Is there a way that you can just like forward the slides? Like whatever you did just now, we can
yeah,
see the digital asset management in manufacturing with the percentage and the kind of the 3 rows of information.
yes. So for me to change the slide, I have to do the play button, and then okay. I think
Did you do the play button and then hit escape or something to go back to the?
yes, correct.
Okay.
So I hit the
Maybe
play
you have to
button.
do that. Maybe play, get to the slide, and then hit escape. Because we're not seeing the play button, I don't think.
Okay.
Just so you know.
Okay, that's a good insight. Thank you for that. So I will hit the play button, get the current slide, and then hit escape again to change.
Yeah, to change views or something.
Okay.
Yeah, sorry
Okay.
for the interruption, but this is great.
Okay. So since we weren't able to see the screen, I will repeat one more time so that we are all on the same page. So DAM is a term which is used left and right in manufacturing, and that is organizing, storing, and retrieving rich media assets, managing permissions, metadata, and rights at scale. It's very different in manufacturing because manufacturing 4.0 DAM must handle 3D models, assembly flowchart, inspection schematics, and SOPs to process, all connected to PIM and ERP. Standard DAM tools weren't designed for this. PIM knows what the product is, the ERP knows what it costs, but when an engineer saves a flowchart, it's just a PNG. A system sees it as a flat image, and there is no connection to the product, no searchable step, just the bytes. And in a typical mid-sized organization, there could be tens and thousands of technical drawings, which can be manually tagging, but it's very time efficient and resource intensive, and it doesn't scale, which is like a $0 searchable value, and it's just like a dump file. So DAM manages assets, but what about the process knowledge? Now, this is a quote by Gartner in their 2025 late 2025 December report that AI is shaping DAM, splitting vendors between those who drive the automation content and then those who are doing traditional marketing needs. AI feature race. AI is everywhere, and that's not a differentiator anymore. What is not present today is OCR, which is optical character recognition, and it has huge capability. But again, OCR alone just gives us the floating words, no structure, no logic, no graph. So what benefit is a OCR with the AI capability that can give you an insight, plus converting that into a knowledge graph which knows all of the ecosystem, and then you can query and search any insight or take any decisions later on. So I'm using today two Azure AI services, Vision and OpenAI. Now it may sound very intensive, but Azure AI Vision will govern like an eye, which will capture the caption, tags, objects, OCR with the bounding box coordinates from a raw visual data. Um, Again, that will not have any reasoning capability, no inference, just a NuGet package. And that when it is clubbed with the OpenAI, now again, GPT 4.1 is a little bit older a model, but for the demo purpose, 4.1 is like a brain, which will take that classified OCR blocks and then convert it into steps and decisions or branch labels, and fragment that text. Again, these two services work hand in hand, and one alone is not good enough. However, setting up Azure Vision is very easy. The first step is to do the provision, for example, creating the resource, and the free tier for the demo purpose is sufficient enough, is what I need today. You can The Microsoft Azure also has a capability for Vision Studio, or it's now called Microsoft Foundry. Inside it has a Vision Studio where you can upload your image, for instance, and then you will get the caption, tag, and OCR lines, which is again good enough to know if your image quality is good enough. And then it will generate the keys and endpoint when you created your resource, and that simply can be integrated into C# SDK. That's what I have done today. For instance, in this application that I will just show in a moment, I'm using 4 features, which is caption, tags, objects, and read OCR. Now, caption is like a natural language description, which is overall of the image diagram, what it signifies. Tags could be the arrows, the decision, the rectangle, the square, whatever is in the flowchart. Now again, if it's not a flowchart and just the image, then the tags will be the diagram. Now objects could be a person, a cat, a dog, which will have the bounding boxes around the detected objects, and that's how the object is. Usually I have seen in the manufacturing, the object part is kind of not there. Why? Because it's little difficult to identify some machine or wire as an object. It's not yet there. That's what I mean. And the OCR, again, optical character recognition, is helpful and is the workhorse, because it tells you based on the bounding text where your image falls in the overall image, where your object, falls in your overall image. Now, the last slide was what you are extracting from your image, and this is more about spatial reasoning, which means how you are going to utilize what you extracted. And for that, you have to first, if it's a flowchart, you have to sort it by the order from top to down. You have to go from top to down in your flowchart, and then also whenever you find the object, you have to bound the polygon X and Y vertices, which is left and right. Excuse me. And based on that, you have to, and after that is done, you have to give the result as a sorry, excuse me, steps and decisions. So before we jump in, I just want to explain the architecture of the application. So first, very important is the image input, and that's the starting point. The second is it goes into the Azure Vision Analyzer, where you get your, again, as said, caption, objects, tags, OCR lines. When it is clubbed with the OpenAI API, it gives you the insights in the form of steps and decisions. Why I keep on repeating steps and decision is because of the flowchart. Flowchart always has a steps, and then based on what step you are in, yes and no, you make a decision and get to the final end. Now there are two parts after that I am taking, which is the graph building for the manufacturing data set, and converting into a knowledge graph that will give me insight if there is defect between two products, or if the defect is same in the two products, and then the insight. And the second part is if there is a pure flowchart folder processor that will give me caption, tag, object, insight, steps, decisions, and then based on that, this information, which is in a JSON structure format, if somebody want to query, because I already have the OCR, I can query the steps and then figure out what does the flowchart tell me. Just a little bit about the knowledge graph. Usually knowledge graph, and how the knowledge graph is built is you have the image node and then the edges. So it makes a relationship. For example, let's say two product, a cable and a screw. If they are broken or have a crack, then there is a relationship between them, which is a defect relationship. And if it is similar and it is used in the same equipment, then you know that these are the two products which have similar kind of a crack or a defect, and they are related to each other. So this helps a lot. Again, the value found in this is by engineers. So I'm quickly going to show a demo. So here, Frank, I think I might need help over here.
Okay.
Because I'm seeing my slides still and not my...
Yeah, there's a way to share your screen.
So I might have to stop sharing this.
Yeah. Okay. And when you go to share again, then you share the other screen.
Yes.
I'll tell you when it comes up. Yeah, here we have it. There you go.
Okay.
Yep, we can see your code.
Okay, nice. So as I said, we have a data set, and that's anomaly detection. Again, this is a public data, and this data has is segmented into cables, screw, transistor, which is very common in manufacturing, and it's broken right and left on the floors everywhere. So that's number one. And then the number two is the flowchart over here. again, this is the synthetic data, but at par with the real flowchart that we use in the manufacturing. So I have 3 of them here. So those are the 2 data sets. Now, I have already compiled and the data is already processed because I did not want it to take a lot of time. So I'm going to get that knowledge graph from my cache. Now here I have 14 query menu that I think is very valuable from the manufacturing standpoint. Now I want to let you know that all from 1 to 12 belongs to the data set, which is MVTech, and then 13 and 14 is for the flowchart. So as I said, to figure out in each of the product type, if I just want to know what are the defects in the different product type. And then, as I said, as per the data set, we have screw, cable, grid, metal nut, and transistor. So for now, I just want to say in the screw, and then I get the defect type. It is the thread top, is the scratch neck, it's manipulated front. So and then the severity is medium. So it's not that the screw is just broken up. It's broken from the top, from the middle somewhere or something else. Now, if I want to find the similar defects across the products, just waiting for the response. And over here, we have, for instance, the transistor and the metal nut. And then I have inside that both involve in deformation of metal components. Again, what happens is this goes into, now at this point of time, as I said, I'm using Azure OpenAI, so I get the insight in a much more explainable way. And one of the thing that I find very much valuable is in number 9, which is give me the complete dashboard understanding. So as per the data set, I get the insight. What is the most common defect, cross product patterns, and the severity, and the equipment priority, and the product complexity. And then these are just the heat map that I have. And most of the products that I have in the data set are in some or the other form bent. None of them are high severity, all of them are medium severity. And if I want to export to the file, I might just say yes. Then this text can be given out to whoever the concerned team is. Now I do want to take you back to the slides.
Yeah, we can see him there now again.
Great. So as I mentioned, in the demo one, I have the key insights for each of the product. I have the full analytics dashboard, and then this can be circulated across the product pattern, across the team. So as I just had shown in the option 9, which is the full full analytics dashboard, which will give me the key metrics, the top insights, the defect type. Again, this picture has a little bit more of the data set than I had, because I just wanted to process with the small data, and the severity breakdown and the defect by the product. And these are just the results that I captured from the output. Now, for the flowchart analyzer, again, taking back to my code,
Yeah, we can see it there now. Yeah.
thank you for confirming. So as I said, these are the three graphs that I have collected. Again, the graph are check the equipment runtime hours. The another one is why the current production run is stopped. And then the third one is if there is any new component from the production line, and what should be the next. So continuing into my the query console, which is 13. So as all of three of the flowchart are fragmented, on the console app over here, on the console terminal over here, the result that we see over here is from the Azure OpenAI. So it's giving me the caption, the steps that are in the flowchart, the decision, the branch label. Most of the flowchart usually has yes and no as a branch label, but some of them have different. And what are the key insights from this? It's like prioritizing, measurement, verification, detective component, and then the name JSON. So have that for all three flowchart. And there is a common theme across all the flowchart. That's what, again, Azure AI is doing. And where the Azure Vision is helping out is when it creates the .json file. So you have the name, you have the caption, as I multiple times said, you have the tags, the object in Azure Vision, as I said, is a little bit of a limitation. It doesn't recognize the rectangle, the square. The object for them is like a dog or a cat or a real person's face. And then you have the OCR lines, which is object character recognition lines. And then, as I had said, it's organized as a bounding box, left and right, top. So you get the exact location of where the rectangle box is, or where the square box is, or where the diamond box is, and that gives you all of the information right here. And then I have actually concatenated the steps, the decisions, the detailed caption, and the process this information is from the Azure OpenAI. Why so is because since this is detailed, it helps me out to query if I have to, which again I will just, which is my, in this, all the keywords that I have, for example, check, log, schedule, assign, verify, record. These are the queryable words which I can use to further know which word or sentence belong to that flowchart. So for instance, number 14, and for example, if I take one word from here, which I just saw, verify. Now there is verify tooling in the flowchart number 2. So for example, flowchart number 2 does have verify tooling. This makes any of the text inside the box queryable. And this insight is more valuable to someone who is into business, into manufacturing, or someone who is editing or changing the processes and want to know what happens or to figure out what's going on or what's wrong in the flow. Then this is a value for them. Going back to my slides again.
Yeah, we can see it there now.
So just the same thing that we just saw, flowchart analyzer, where you can segment the whole flowchart into captions, tags, OCR lines, etc. And then from the JSON file, you can query any other word and figure out, correct, edit the flowchart. One of the flowchart that I had just shown about the component, getting new component from the production line, and how it is structured into a JSON format, and you can query any of the text from this flowchart and use that as an insight for a cross-functional team. Again, this talks about the output contains that we just show. We just see caption, tags, steps, decision, and steps and decision. Also, we get from the Azure Vision, but to be able to give more explanation and enhance enhance and summarize the steps and decision, it was given to the OpenAI Azure as well. This is the output that I just showed, where I put the verify keyword, and that will give me, it's in flowchart 001 or flowchart X, Y. Again, my data set is limited just to 3, but if it's hundreds and thousands, and you don't have to go one flowchart to another, but if you have keyword or if you have sentence in the mind and you can search, then this is a value addition for that scenario. Of course, there are limitations. As I have seen, the image quality has to be really good. That's the key point over here. If it's more colored, dark pictures, then the image did not work for me. I did try sometimes to extract the domain knowledge. is quite difficult to extract, and having an ambiguous arrows is also one of the limitation. Again, governance is the big point. The sensitive engineering diagrams need control before sending to all this cloud API, so that's a limitation. And talking about the accuracy, if the flowchart is clean, just a black and white, then you have the good quality caption, the step extraction is good, the decision detection is good, and it's also production ready. But if it's a scanned PDF or a whiteboard photo, it didn't work at all. So there is a lot of improvement in required in that. And if it's a raw or a pre-processed, it's just not there yet. So the key is to have a clean digital flow chart for this kind of use case for now. What's real in this market? In last 2 years, digital asset has been exploding. The manual tagging and the storage can't keep up. So every manufacturing organization is kind of digitizing decades of paper documentation at once. However, the unstructured data dominates at this point of time, because there are lots of images, lots of PDFs, a lot of videos, a lot of thermal videos, and that is making up the enterprise data majorly. But AI metadata and AI metadata is a competitive edge in this era right now, and DAM is shifting from store and retrieve to auto tag, auto describe, auto connect, searchable query, and etc. However, more and more AI is coming into the business, so governing is rising at an urgency, I guess. So the basic idea over here is a search to, again, can go to agentic action as well. It can be possible that after the insights are there, it might take its own understanding. The agent might take its own understanding and change the flow chart, the processes, and then put the human in a loop, and then get the human to correct and look into the flowchart. So this can be the future foreseen of DAM. So my grounded prediction is now there will be more and more domain fine-tuning, where there will be domain-specific diagrams such as BPMN, UML, P&ID, electrical schematics, a big thing in a manufacturing. And then a multimodal knowledge graph. Today, there is knowledge graph for the image, but there will be multimodal knowledge graph where videos will also cater to the importance of the insights in the coming future. And just 3 things to take away is the gap is smaller than we all think. The limitations do lie, but it's not a bug, it's an opportunity. And knowledge graphs can be scaled. So yeah, that was my talk. Thank you.
Thank you very much. And that was a great presentation. A lot of detail in here. And we have somebody from LinkedIn there put this up on the screen. I'm happy I found it. Learning never stops. So thank you very much.
Thank you.
So Precious, I'll put your screen up. There we go.
Hi everyone. That was a nice presentation, Reddy. You did well.
Thank you.
Okay. I guess there are background noise coming from my end. Apologies for that. I'm going to go over to what I have for today. Welcome everyone once again to Azure and AI Show. If you cannot hear me very well, please call my attention to it. I would be audible enough. So today, I'm going to talk about Azure Load Balancer. Azure Load Balancer is a cloud service that distributes incoming traffic across back-end virtual machines or virtual machine skill sets. Azure Load Balancer keeps application highly available, scalable, and resilient under heavy traffic. This presentation summarizes core advantages, availability, massive scale, layer 4 traffic handling, flexibility configuration, health monitoring, and SKU choices. So you can quickly map its capabilities to your architecture. So now let's understand the key benefits of Azure Load Balancer. Azure Load Balancer guarantees high availability. It distributes traffic across multiple back-end virtual machines or virtual machine skill sets to ensure apps remain online even when instances fail. Now, it also guarantees reliability. Built-in head probes automatically dictate unhealthy instances and remove them from rotation, preventing traffic from reaching faulty backends and maintaining service continuity. Going over to my next slide, I have one of the benefits is also the ability to scale for heavy workloads. It's designed for extreme scale. Load balancers can handle millions of requests per second with ultra low latency. It suits large scale and rapidly growing applications where consistent performance under massive concurrent load is essential, like web platforms, streamings, games, and real-time services. Now, load balancers operate at transport layer of the OSI model. This makes it appropriate for broad range of workloads, for standard web traffic to latency-sensitive UDP services. The UDP feature supports low latency, connectionless traffic, ideal for gaming and real-time streams, while the TCP feature supports reliable connection, oriented traffic for traditional web and API services. Now, Azure Load Balancers have two features, which is the public and the internal load balancers. The public load balancer handles inbound internet traffic that's coming to the virtual machines, and it's ideal for internet-facing applications and services, while the internal load balancers balances traffic within a virtual network or a hybrid environment for just internal services. It also offers automatic health monitoring. The health probes continually monitor back-end virtual machine health and route traffic only to the healthy instances. This constant monitoring improves reliability and user experience by preventing requests from reaching degraded or offline servers. This is one of the capabilities of Azure Load Balancer. It also has the flexibility of configuration. So there are key components to look out for while configuring Azure Load Balancer. We have the front-end IP, the back-end pool, load balancing rule, the NATs, network translation application, the NATs rules, This component allows precise routing and connectivity patterns. So these are the components to configure while deploying a load balancer. The front-end IPs, the back-end pools, the network address translation rules. That was what I tried to mention earlier. The load balancing rules. Now, these options let architects design predictable follovers behavior, scale patterns, and secure inbound, outbound connectivity while delegating infrastructure management to Azure. I'm going to talk a bit about the load balancing rule because it is the major. It's not the major, but it's it's what makes sure that the traffics are being distributed evenly. Then the front end IP ensures that the back end pools makes use of just one public IPs. Then the back end pools are where the series of virtual machines or the virtual machine skill sets are being deployed. Then the NATs, network address translation, it's direct traffic specifically to a specific virtual machine at the backend pool. This Azure Load Balancer is also a fully managed service, enabling Microsoft handle the underlying infrastructure, updates, and maintenance. You focus on application architecture and policies rather than managing load balancer hardware or software, reducing operational overhead and risk. So there are different SKUs, can call it tier, the different tiers of load balancer. You have the standard load balancer, which has high performance and high availability for production workloads, requiring scale and SLA guarantees. And also the gateway load balancer, it integrates with network virtual appliances like firewalls and IDPs and IPs for advanced network functions. Also, there is one which is already retired, the basic load balancer, which is basically for testing scenarios. So in my summary, I have Azure Load Balancer delivers, which is the basic duty, delivers high availability, extreme scale at layer 4 TCP UDP support, internal and public routing, automated health monitoring, flexible configuration, and manage SKUs. When designing deployment, align SKU choice with scale and security needs. Use head pros for the resilience and configure front-end, back-end rules with NAS thoroughly for predictable traffic flow. With this basic explanation to Azure Load Balancer, I'm going to go over to my demo, which I have already put up some stuff. So before I go ahead to confirm my load balancer rule, I have already created the virtual network. This is my virtual network. In the virtual network, I have the back-end subnets. In the back-end subnet, here we go. So this is my back-end subnet. I have already deployed it. I don't want to take too much of our time. I've also configured 2 virtual machines on this back-end subnet. This is for my Azure version, which I'm going to use to log into my virtual machine. Also, I created a load balancer and I configured the load balancer rule. So this is my load balancer. And I did all these configurations already. This is my backend pool. I've already done my back. I've already connected the VMs to the backend pool. I have already configured my health probe. Like I said earlier, it checks the healthy virtual machines at the backend pool for appropriate distribution of traffic. So this is my load balancing rule. This is where you will find the, yes, here you go. This is my rule already. I have configured this rule. So I'm going to go over to my virtual machine, which I have already connected. And as well, I've run this ISS server script to confirm that my back-end virtual machines can actually use the front-end IP of the load balancer to communicate to the internet. So what I did basically, I came over to this public IP, my load balancer front-end IP. Another thing to note is that you can either use the IP prefix or the IP address, but in this demonstration, I use the IP address. So this is my front-end IP address. I copied this. I've already connected my VM and did the necessary configuration I had to do through PowerShell. So this is just the demo I have for today. This is for my VM2, and this is for my VM1, which I did before coming up to this live show. So thank you everyone for having me. I know it's a very short one. If there is any question, I'm here to take it.
Very good, Precious. That was very good, and everything worked. That was good.
It was awesome.
Yeah.
Thank you.
It's good, Precious and Reddy.
So another thing I want to encourage beginners like me is to always clear up your resource, because what I did is just for testing. It's fine. I don't mean to do that on the show.
Yeah.
So thank you everyone for having me today.
That's actually very, very good, because when I started on Azure before as well, I'd done a demo and I spun up a virtual machine, but I forgot to turn it off. And it kept running for a week. And next I got a bill for $80. So yeah, okay. Make sure you spin down everything after you spin them up. Yeah. Thanks, Precious, for that.
What I do basically is to use the bash to clear up the resource group. That's where every resource I deployed for testing is already out.
Very good.
Thank you very much.
Okay, cool. So, Venkata, up to you. You want to share your screen there?
Sure.
Yeah, I have it there. We can see it. Yeah.
So, are you able to see my screen?
Yeah, we can see it there. Yeah.
The cloud innovation health insurance. Are we on the same page?
Perfect.
Hey, yeah. Thank you for giving me the opportunity. So I'm glad here. So thanks, Precious and Reddy. So it's a fantastic presentation. So today's topic is cloud innovation in health insurance, which is driving efficiency with Azure and artificial intelligence. So you had coming to me. So my name is Venkata Prasad Anantavaram. So you can call me Venkata. I bring around 18 years of experience in the IT industry, working across diverse technologies and enterprise platform. Over the course of my career, I have been involved in designing, developing, and optimizing scalable systems that support large-scale business operations. Currently, I'm working as a senior consultant at Infosys and Blue Shield of California, which is a healthcare company and health insurance, where I focus on leveraging cloud technologies and modern engineering practices to enhance operational efficiency and drive innovations within the healthcare insurance domain. So you may see my experience spans cloud architectures, system modernization, and artificial intelligence-driven solutions, particularly in the environment where security, compliance, and performance are critical. Today, I'm excited to share the insights on the cloud innovations in health insurance, driving efficiency with Azure and artificial intelligence. How organizations can harness the power of cloud platform and intelligent technology to transform healthcare operations. So going to the first slide. So today we are going to this on the first slide, the digital transformation in private too. So like health insurance today face like mounting pressure to modernize operations while simultaneously controlling costs, and navigating increasing regulatory complexity. And legacy system fragmentation, data environments, and manual process happen, slow innovation, and limit eligibility. So you can see there are challenges and driven solutions like traditional challenges and what other traditional challenges and cloud solutions. So here Microsoft Azure offers a cloud-native foundation that enables transformative change by leveraging scalably infrastructures, platform services, advanced analytics, and AI capabilities. Insurers can modernize the core system, improve operations efficiency, enhance compliance, and deliver better member and provider experience. So obviously, finally, it's a good, better experience for member and provider. Yeah, cloud native approach is not just a migration, it's about re-architecting for resilience, security, and scalability and innovations. So here, what Azure integrated ecosystems organizing can accelerate digital transformation while maintaining the governance and regulatory standards essential in healthcare. So mainly the digital in transformation imperative, the health insurance organizations are at critical turning points. The demand for faster service, improved member experiences, regulator compliances, and cost efficiency is accelerating. However, traditional operating models continue to present significant challenges. So the few of the traditional challenges are like the legacy system, limiting agility, slow claims processing cycles, rising operational costs, fragmented data ecosystem, manual fraud detection gaps, and the coming to cloud drive solutions. So it's to address the traditional challenges, insurers must adapt a cloud first, intelligent operating model built for scalability, resilience, and innovations. Here you can see that like few examples are real-time data processing, custom optimizing and scale, and Unity Analytics platform, and elastic scalable infrastructure, and AI-powered intelligence. How the AI-powered intelligence is embedded AI and machine learning, enhance fraud detection and automated claim adjudication, personalized member and engagement, and improve risk prediction. Instead of reactive system, insurance gain predictive and proactive capabilities. Coming to next slide. So here in this, we're checking the foundation for healthcare innovations. So what is the foundations, how it grows? In the rapidly evolution of like healthcare insurance landscapes, innovation requires more than the incremental upgrades. It demands a secure, scalable, and intelligent digital foundation. So here, now coming to Microsoft Azure provides the foundation by combining enterprise-grade security, regulatory compliances, and advanced analytics and AI capabilities within a unified cloud ecosystem. So Azure capabilities powering innovation, so mainly elastic compute, advanced analytics, and integrated AI service. Coming to elastic compute, how it is leverage the elastic infrastructure of Microsoft Azure to dynamically scale compute and storage resources based on demand. And coming to advanced analytics, so how the transform raw healthcare and claim data into actionable insights using integrated analytics and business intelligence tools. Here, this advanced analytics, you can see the centralized data from claims, providers, members, and pharmacy systems. Enable real-time dashboards and regulatory reporting, support predictive modeling and risk stratifications. And coming to this one, integrated AI service is kindly deploy the machine learning models and cognitive services without requiring extensive in-house data science expertise. So it's barely deploying the machine. So here you can see the examples like automatic claim adjudication, defect fraud, and anomalies in real time, enable intelligent document processing. So how the transforming core infrastructure operations. So here mainly the digital transformation in health insurance is not limited to infrastructure modernization. It fundamentally reshapes core business operations. By leveraging Microsoft Azure and AI-driven capabilities, insurers can re-engineer mission critical process for speed, accuracy, intelligence. The key benefits of like claim management, fraud detection, member engagement. So how the claim modernization is working on, so automate the claims intake using intelligent document processing, enable real-time adjudication through real engines and AI models. So it helps to reduce processing cycles and improve provider satisfaction. So it is kind of minimize the manual intervention and operational bottlenecks. how the intelligent fraud detection, member engagement, so data-driven underwriting and risk management, these all are key benefits for this insurance operations. And how Azure enables insurance to modernize this critical business process with the cloud native architectures that deliver speed, intelligence, and reliability. And mainly the data-driven here use predictive models of risk scoring and pricing optimization, integrated clinical claims and behavioral data for holistic insights. So coming to the next slide. So this is the real-time claims, how the real-time claims processing excellence. So in the coming to health insurance, modern health insurance must provide beyond batch-based processing like tidal batch, so toward real-time intelligent claim operations. So with the elastic infrastructure of Microsoft Azure, organization can process high volumes of claims, like millions of claims, like at unprecedented speed while maintaining accuracy and compliance. Sometimes we can use EDA claims like electronic data agencies. Some people like you're still using paper claims. There are many applications like FaceSets tool, like TriZetto Medical Solutions. In the TriZetto, you can use the claims like that. So here, Azure Scalable Compute, even data-driven architecture enables real-time data processing, accelerating decision-making. So some key capabilities are here. You can see the intelligent document processing, so which is AI-powered optical character recognition. So here extracts structured data from unstructured documents, such as claim forms, UOBs, and medical records. And automated adjudication rules, real-time eligibility verification, exception handling workforce, audit trial generation. It's a kind of end-to-end digital facing providers full transparency for compliance reporting and regulatory audits. So then how artificial intelligence provide the fraud preventions. So here fraud detections in healthcare insurance is no longer effective. With a static rule-based system alone, modern fraud systems are complex, coordinated, and constantly involved. So it's requiring intelligent adaptive detection models. With Microsoft Azure AI capabilities, including Azure machine learning and cognitive services, that strengthen anomaly detection by analyzing millions of data points across like claims, provider patterns, and members' behavior. So how the advanced models identify sophisticated fraud schemes that avoid data like traditional rules which are based on the systems. So we have like key benefits: annual healthcare fraud, the detection accuracy, and faster investigation. Coming to next, the data interoperability advantages. So here you can see the mainly in the healthcare, you can see the providers, payers, so pharmacy, labs and diagnosis and the claims, like member enrollment, these things, how it works. So in healthcare insurance, data is one of the most valuable assets. So here you have been fragmented across claim system, provider network, pharmacy platform, care management tools, and member portals. Like true innovation happens, how these are eliminated. So here cloud-based data platform breakdown information silos, enabling secure exchange across the healthcare ecosystem while maintaining HIPAA guidelines and GDPR compliance standards. So that is a major challenge. So we need to maintain the guidelines and compliances. Coming to the how the security and compliance at scale. So in health insurance, security and compliance are not optional. They are foundational. So insurance manages highly sensitive member data, including PHA data, financial information, and clinical records. Any transformation initiative must be built on secure and compliant architecture from day one. So here, like Microsoft Azure provides enterprise-grade security and regulatory compliance capabilities designed specifically for highly regulated industries like healthcare. So like HIPAA guideline compliance, GDPR guidance, industry certifications. So this is how it works. So in health insurance, the security and compliance are not optional. Now coming to next slide. So here you can see the hybrid and multi-cloud resilience. So in this, we have the strategy flexibility. So how the digital transformation does not require an all-at-once migration. Many health insurance operate complex legacy ecosystem that must contain running while modernization progresses. Here, like Microsoft Azure offers robust hybrid capabilities like that allow to maintain on-premises systems while gradually migrating workloads to the cloud. This phase low risk approach enables like incremental legacy modernization, reduce operational disruption, seamless integrations between cloud and on-prem systems. It's kind of control the migrations aligned with the business priorities. So multi-cloud strategies, which provide a vendor diversification, improve disaster recovery, and ensure business continuity. And it has data sovereignty and governance controls that enables insurers to meet regional, regulatory, and compliance requirements while leveraging global and cloud infrastructure. So then how the operational cost optimization. Here, cloud native architecture eliminates capital expenditure on hardware while reducing operational overhead. So here can you see how the infrastructure and how the Azure cloud is helping to cost optimizations. So pay-as-you models align cost with actual usage, and automated scaling prevents over provision wastage. Here we can set by using the cloud and AI, so we can optimize the cost. Next, elevating member experience through digital engagement. So here we have them key benefits, mobile first platforms. Nowadays we can see the telehealth integrations, so no need to rush to either emergency or urgent cares. So we can use the telehealth integrations, and now AI assistants also helping us, how it will be. So kind of mobile first health platforms empowers members with instant access to claims, coverage, and benefits anytime, anywhere. And coming to telehealth, how it helping, and how the AI assistants are helping, delivery instance, intelligence support around the clock, answering questions and guiding members. So what the plan they can choose based upon their diagnosis and their requirements. So what are the benefits they are getting the combination of plans. So the AI is helping anything. So how the from transaction to intelligence driven healthcare. So here we can see there are few for key benefits, the traditional model, so which is reactive claim processing and administrative focus, and how the cloud adoption adapted automated workflows and data centralization, and artificial integrations, so which predictive analytic and pattern recognition, and proactive care, so which help a population health management and preventive interventions. So yeah, so I have I won't take much time, so I think I'll complete in 10 minutes. So next one is architecture best practice for success. So here how can architecture start with outcomes and flows, and we can come up with the design for scalability, and how can you prioritize data quality. So we should implement the security by using design, and how can enable the continuous innovation. So adapting DevOps practices and continuous integration, continuous development pipelines like CI/CD to accelerate features delivery and reduce time to market. So the value-based care features. So here you can see the cloud-enabled capabilities. So it can help population health analytics, risk stratification models, care gap identifications, provide performance tracking, member engagement programs, and coming to the business impact. So which impact reduce the hospital admissions, lower total cost of the care, improve quality scores, enhance member certification, competitive differentiations. So these are value-based care features. And coming to value cloud transfer journey. So here we can see that one SSS and plan. How can you plan that one? Design scalable architecture, and how can select appropriate Azure services, establish migration roadmaps, and how can you implement. So by using and we can optimize the cloud. So by using monitor performance, refine models, and continuously improve operational efficiency. So Azure AI services for healthcare. So here you can see it's helping mainly documentation intelligence and predictive modeling, AI-powered member support, FHR interoperability, which is leveraging Azure Comprehensive AI service to transform every aspect of your insurance operation from back office efficiency to frontline member engagements. So coming to real world success metrics, so mainly the 5 key benefits like these are claim processing, member satisfaction, fraud detection, operational cost, system optimization, and which help like Azure cloud adoption delivers tangle measurable benefits for health insurance providers. So next, predictive analytic and population health. So here Microsoft Azure leverages advanced analytics, artificial intelligence, and risk satisfaction, predictive modeling, and care gap analysis, SDOH integration, personalized interventions. So mainly risk stratifications, which predictive models identify high-risk members before a adhesive events occurs. Insurance can proactively intervene through targeted care management programs, reducing hospital admissions, emergency visits, and overall healthcare costs. So like chronic disease forecasting, how can chronic disease? So machine learning algorithms analyze historical and real-time data to forecast disease program trend, and it enabling preventive interventions and optimize resource allocations. So like when you're coming to the fraud and waste abuse detections, predictive analytics also enhanced financially sustainably by identifying anomalous claims pattern and reducing fraud related losses. Next, we can see overcoming legacy system challenges. Here mainly you can see modern enterprise, especially in healthcare and insurance, often rely on outdated legacy system that limits scalability, interoperability, and innovation. So it's overcoming the challenges is essential for achieving digital transformation and operational efficiency. So mainly interoperability barriers. So here like legacy platforms often operating with the priority data formats, adapting standardized APIs and integration framework enables like seamless data exchange across the systems, improving collaboration and real-time decision making. So and one more thing is high maintenance cost. So it's maintaining the aging hardware and software increases operational expenses, and technical debt, transitioning that to manage cloud service this maintenance overhead and enable team to focus on the innovation rather than the system upkeep. And next one is security compliance risks. So here legacy system may lack modern security controls and encryption standards. So which is upgrading to the contemporary architecture strengths, cybersecurity posters, and ensure compliance with evolving regulatory requirements. So next we can see last one, building a data-driven cultures. So achieving a truly data-driven cultures requires more than developing advanced technologies. So it demands organizing element, leadership commitment, and workforce enablement. So Microsoft Azure supports the transition by providing an integrated ecosystem of analytics, AI governance, and collaboration tools that empower teams to make informed evidence-based decisions. So mainly like the best key benefits like leadership driven strategy, democratic data access, data governing on trust, and skills development collaborations, and continuous improvement and mindset like mature data, how it helps me say mature data culture, emphasis measurement, experimentation, and iterative learning. So here Azure scalable infrastructure supports rapid experimentation, model deployment, and performance tracking, driving ongoing optimizations. So by aligning these all technology with people, process, and governance optimization can move beyond data collection to true insight generation. So creating culture where decisions are constantly guided by the measure and evidence and continuation. So this is about Azure and AI. Thanks for understanding. So anything you have that?
That's very good and very informative. It's great to kind of see, you know, how AI and Azure is really kind of moving things on, especially in healthcare. Like it's could see the costs of moving to the cloud rather than on-premises infrastructure. Like it's great. Any questions?
Great presentation. I don't have any questions per se.
Okay. So we had a great mix of stuff now, from healthcare to manufacturing to load balancers this week. It's great. And then we had two women, and we had Reddy there with her first presentation. That was great.
Yeah.
Thank you, Frank.
Thank you.
Thanks for joining.
Yeah.
Thank you for giving the opportunity.
Thank you.
So yeah, we had this one. Happy I found it. Learning never stops. That's great. So yeah, as I say, we kind of normally go over time every week, so that's okay, and we're happy, especially when we have new speakers on, to give them time. And thanks very much for joining us again this week, and we'll be back again next week with some more new speakers. And thanks.
Thank you.
Thank you. Thank you, Frank. Thank you, everyone.
Thank you, everyone.
Thank you.